We are ready to continue with part 2 of our review for the Unit 3 test coming up. Starting up at number 34. The polynomial function f of x equals x to the fourth plus 3x squared minus 4 is the expanded form of which of the following? In other words, if I were to factor this, what would I get? Well, I might want to start by trying to factor this out first. And again, treat the x to the fourth just like you treat x and x, is the order x squared. Do it like you would a diamond. So if I have two numbers, I need to multiply to negative 4, but add to 3, I'd have positive 4 and negative 1. But then look closely, I have a difference of squares. So I take care of that part. X plus 1, x minus 1, and x squared plus 4. Because again, there's no such thing as a sum of squares. Don't break that down to x plus 2, x minus 2, or any other bunch of whatever you can come up with. That's all we're going to have on that one. Here, you got to know the pattern. What do I cube to get each? I cube 2x and I cube 5. Seeing the minus in the middle, I know A and C are not the answer. The only difference between these two is this sign, and again, we know the signs have to change. That's going to be B. Again, take advantage of the fact that it's multiple choice. You don't have to actually work it all out then if you can just eliminate a couple of simple things. 36, again, we talked about it a little bit physically in class. I'll move this down just a little bit so we can get this back up here again. Talking about the general basic exponent rules and how to deal with those. So these are the guys I need to be keeping an eye on. So here I look and I'm like, okay, these are different bases. A to the third is going to stay. B to the negative third. Negative exponents need to be flipped. In other words, this is in the numerator. I need to flip it to the denominator to make it positive, because you never, never, ever have a negative exponent in your answer. Ever, ever, never. Ever. On this next one, I have a choice. I notice I'm power to power with squared, so I'm going to be multiplying exponents. But I also notice I have a negative. I could flip. I can do either. Most of the time with these, I go ahead and choose to get that exponent through there first. 1 squared is 1. Negative 3 times 2 is negative 6. 3 times 2 is 6. But again, no negatives in the answer. Flip it up. B stays. It doesn't have to do anything because it's already positive. It doesn't need an attitude adjustment. And as we keep doing these, negative, flip it down. Here, I have the same base. So when you're dividing, I take the big exponent minus the small, greater valued minus the smaller valued. 4 minus 1 is 3. Answer goes where the bigger exponent is. But be careful. Don't just circle this, because right now, there would be no denominator if I circled it. Since those are in the denominator, you have to have the one there to hold the place. Okay. And here, power to power again. Move that negative 3 through. We'll talk about this in a minute. Multiply your exponents, power to power. Negative 3 to the third. This doesn't work the same. I'm not adding here. It literally is negative 3 to the third, negative 27. X to the sixth can hang out. The only thing that needs to flip is x to the negative 15th. Now you're like, well, wait a minute. If I flip that, I don't have to flip negative 27, negative exponents only. So, one last thing I need to do. I'm dividing. I need to subtract my exponents. 15 minus 6 is 9. Larger valued exponents in the denominator. And I'm good to go. Okay. So those are the type of things I need to be remembering with these as I'm doing my exponents. Okay, I've got a negative 2. Again, I could do lots of things. I could go ahead and just determine, hey, that negative just means these are going to flip up and these are going to flip down. So could I rewrite this, flip them, and just change that to a positive? I can. Or you could distribute through at the beginning and then start doing your flipping. That's okay. But this way, at least, I'm going to be able to work through this. And don't forget about the 3. Square it too. And now I need to do a little simplifying, but I notice right away there's only a 9 in the denominator of b and d. Let's see, what's the difference? The y's. Here's my y's. 10 minus 2 is 8. Larger exponents in the top. There's my answer. Okay. Find the remainder when this is divided by x minus 3. Now I have a choice. I could do long division, use the x minus 3, or since it's just linear with x, I could choose to do synthetic here, but remember, if you do synthetic, since it's x minus, it's a binomial term, you have to change your sign. So instead of minus 3, it'd be plus 3. So that would be my suggestion, especially when given a choice. Bring down your first term, multiply, and add, multiply, and add, multiply, and add. And since it's just asking for the remainder, it's asking for the number on the end. I'm good. 39, if p of x has a root of 2 plus 4i, which of the following is another root? Remember, i's, their complex conjugate is also a root. In other words, switching the sign in the middle, 2 minus 4i. That's it. You don't have to calculate anything. You don't have to look at it on the calculator. Nothing fancy like that. Just go ahead and get it done, be finished. Okay, more with our divisions here on the back. Synthetic division. Again, if you're given a binomial, change the sign. Now, if it just would have been x equals, I go ahead and use that. Make sure there's no holes, and there aren't. Bring down the first term, multiply, and add, multiply, and add, multiply, and add. And if I've done things right, I'll have no remainder. Okay? If that's a root, let me take that back. If this negative 4 is a root, I'll get no remainder. And it is, but it's not asking me to find the roots. So here I look and I'm like, okay, it started with a degree of 4. So I go to 3, 2, 1, and I'm set. Okay, don't have to keep going, don't have to use the calculator, just one time through and you're done. And I'm going to go ahead and do 42 right now. I'll come back to 41. And change your sign. Ooh, there's a hole this time because it goes from the third power to the second. I don't see a plain x. So I need to take care of that. Pull down my 4, multiply, and add, multiply, and add, multiply, and add. And again, don't be spooked out if you have a remainder. We're just using division. I started with a degree of 3, 2, 1, 0, and there's my remainder. And I'm set. Okay, we like synthetic division because it goes faster, but not everything's going to go faster every time. It just doesn't work that way. So what we're going to do on 41 and 43 is we're going to use long division. Now, you're going to want to have, or you could probably use the area over here, but I kind of write big sometimes. So we are going to use long division to divide this out. So here's my divisor. And here's what I'm dividing into. And still watch for holes, but there are none this time. So no worries. And this is going to work. First term inside divided by first term outside. And this part's never going to change. So whatever I get goes up here. And then what I'm going to do is I'm going to take that 2x and I'm going to multiply it by my divisor. And whatever I get when I distribute that through is going to be what I put underneath here, but here's the kicker. Here's the one everybody forgets. When you're doing long division, this is subtraction. It's not addition like it is when we're doing synthetic. So 2x to the third minus 2x to the third, cancel. 5 minus 8 is negative 3x squared. Negative 22 minus negative 10, so switch the sign. Negative 22 plus 10 is negative 12x, and I'll bring down the 15. And I start the process over again. First term divided by first term. Take that value, distribute it through to your divisor. Be very careful to watch for signs. And I notice I get the exact same thing, so when I subtract it, I have no remainder. I'm done. Now, am I always going to get no remainder? No. You got to watch out for this stuff. So one more here. Long division. Same way as we just did the one up above, same steps. We'll get our little scratch work here going again. First divided by first. We're good there. So now we're going to take that times our divisor. And again, the nice thing about you being at home here is you can pause me if you think I get going too fast. 6 minus 6, there they go, that's good. Negative 11 minus negative 3, which is negative 11 plus 3, is negative 8x squared. Oops, 2x, not 28. And start the process again. So negative 8x squared divided by 2x is 4x. Multiply that 4x times my divisor. Oh, Harty. Don't lose the negative. That's better. See, that's the nice thing about long division. I noticed right away, I'm like, wait a minute, negative 8 minus 8, that's not going to work. Reminded me that I kind of forgot my negative back here. So negative 8 minus negative 8. Okay, they cancel. 2 minus 4 is negative 2x minus 4. Last time through here. You're like, I got to do it a third time? Didn't even tell me that I was sliding down past the answers here. So negative 2x divided by 2x is just minus 1. Distribute the negative 1 through, because I have my signs right this time. So negative 2x plus 1. And you're like, I have a remainder. That's okay. Negative 4 minus 1 is negative 5. Put that over. Good to go. A little bit of a tedious process. That's why we like synthetic so much better, but that's the way it goes. Okay. Find all the roots of this. Exact answers only. In other words, don't go to the calculator and give me a rounded decimal. That's not what we're looking for here. What we're looking for here is to factor this. And we spoke about it in the last review. I'm going to treat this at the start like it's x squared minus 11x plus 18, because that's something that I can factor pretty easy. Like x minus 9 minus 2 would get me this. What's the difference? Well, now instead of x and x being x squared, it's x squared, and x squared is x to the 4th. But don't stop. This guy is a difference of squares. But again, I want answers this time, so I set each of these equal to 0. I get 2 answers here. Well, that's not a perfect square. Now what do I do? Okay, minus 2 equals 0. Solve it like an equation. Isolate my x squared term. Take my square root. 1, 2, 3, 4 answers. And I knew I'd get them, and I have the exact ones. It's all good. Okay. Now, when it mentions in 45, find all of the zeros, real and imaginary. That gives us a clue. The calculator's probably going to come in helpful. So let's see what we got here. we've got x to the third minus 3x squared plus 7x minus 21. Okay, so I'm looking for all the zeros real and imaginary. Now let's just see, and we're looking at this, let's play with this window. Yeah, let's get back to normal here. So zoom standard. You're like, ooh, I might get one off the chart. That'd be nice. There it is, okay. Anytime y is 0, that x value is one of my zeros. So x equals 3, that came from the graph. Now, that was the only one I saw in the graph. Even if I took my window back a ways, just to see if I could see any more, it still only looks like it's going through that one place. So the calculator's not going to do me much good at this point. This is where I use synthetic division, and since I was given the x value, don't change the sign. No holes. So multiply and add, multiply and add, and add. And since I started with a degree, 3 squared x. So I got x squared plus 7 equals 0. And just like we did up here, I'm going to go ahead and solve this, remembering that when I take the square root of a quadratic, it's plus minus. What do I got to do with the negative? Pull an I out. 2 answers, 3 answers, degree of 3, I'm good to go. Find the zeros. Again, if we want to try to do it the quickest way, we're going to go ahead and we are going to see if the calculator will spit them out at us quick. Otherwise, we got to maybe do some synthetic division. So x to the third minus x squared minus 14x plus 24. 1, 2, 3. Okay, I see they're all going to be real. I see one's at 2. One's at 3, and I notice here, I want to make sure the other one's at negative 4. Yep, there it is. But once I saw 2 and 3, basically multiple choice, I knew what the answer was. 47. Now here's the kicker. Am I telling you to find the zeros? No. Possible. P-value, negative 12. So I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6. Holy cow, plus or minus 12. Okay, I'll fit them all in there. My Q is 5, which is plus or minus 1, plus or minus 5. So the possible zeros is P divided by Q. So when it's 1, it just repeats all of these. So plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, and 6, and 12. But it also is going to include all of these being divided by 5. So 1/5, 2/5, 3/5, whoops, 4/5, 6/5, 12/5. That's a whole heaping lot. But luckily we don't have to figure out which ones they are, because they just want us to find the possible ones that are there. For each of the polynomials, state the degree. Okay, 3. My lead coefficient, the coefficient in front of that, 2. Even or odd, looks pretty odd to me. And my end behavior. Now, there are ways of telling with change of sign and things like that what's going on here. But again, this is going to come back to the reality that we have technology. And when we have technology, we're going to take advantage of that fact to simplify things. So I look at this and I go, okay, my end behavior. Remember, you're always going to have one going towards positive infinity with x, one towards negative. My job is to figure out where y is going when this is occurring. As x is heading to the right, y is going up. As x goes to the left, y is going down. And I'm done. Keep life simple. Degree, If I don't see one, my lead coefficient is 1. It's even. Swing this guy over here. And we'll finish this page up. X to the 6th, x to the 4th, 3x squared plus 2 graph. So here, as x approaches infinity to the right, it looks like my y is going to be going up for both. So a positive infinity for each of my f of x's. And no matter if x is heading right or left, y is going up. So that's how I would figure that out. And again, you can do that visually. We'll keep life simple. Explain how to identify if an expression is a factor of a polynomial. Hint, see synthetic division. When you synthetically divide and you have like x equals 3, and you plug that in, what are you going to get at the end if it's actually a factor? You'll have no remainder when using synthetic division. And that's it. Okay. If 5i is the 0 of a polynomial, we talked about this earlier with the complex conjugates when it's 5i, or any i, what must also be a 0? Its complex conjugate, negative 5i. If I start with negative, I can keep the positive one. 51, with the calculator help. State the number of complex solutions, imaginary solutions. So basically, all I'm going to do is go through here. I'm going to graph it, and I notice I see 2 real zeros. I know there's going to be 4 solutions total. So if 2 are real and there's 4 total, it leaves 2 complex or 2 imaginary solutions. That's all you're doing. Don't make it harder than it needs to be. 52. Use your graphing calculator to find out the following. Okay. Let's get this guy typed in and get this figured out. So we got 4x to the 3rd plus 8x squared minus 7x plus 2. Okay, degree. Now I can get that. I don't need to graph it to get that. Degree. Odd or even? Odd. Name the zeros. Okay. Are we going to get any from there? No. So we got to trap it again. Second trace will get me to the calculate menu. I'm trying to find a 0. I'm going to trap it in. So below and above, because that's left and right. Again, remember, E is just a fancy way of saying 0. So negative 2.71. And again, this should say real zeros. I don't want you to have to sit and do synthetic division with goofy decimals and things. That's kind of silly. Okay, find the ordered pair for the maximum. You're like, the maximum's up here, though. I can't see it. What am I going to do? I change the y value. Change the y value so I can see it. There it is. So give me the max. Left bound just means you got to be on the left side of that point somewhere. Somewhere on the right. Couple of enters. Negative 1.68, 17.37. Minimum, same idea. Except we just use a different part in the calculate menu. And we're looking for this guy down here at the bottom. Anywhere on the left and on the right is fine. You don't have to be the exact same places that I'm at. So 0.35, excuse me. And 0.70. Okay. End behavior. As x is approaching infinity, as x is moving to the right, what's happening to y? It's going up. as x is approaching negative infinity or going to the left, what's happening? Y is going down. State the domain in interval notation. Domain, x values, left to right. Looks like it's going forever in both directions, and that's going to be the case with all these. Okay, now the range is a little more interesting sometimes, but not in this case. Because you notice it goes down forever, it goes up forever. Okay. Graphing the function with 53, again, I'm just looking for a sketch here. I don't have to have utter and complete perfection. What I'm basically looking for, and I'm going to talk about that before I hit the graph button here. Basically, I can tell my zeros are at -4 and +1. And I see with that squared, I'm going to hit a double root or a bounce going one of the directions. There's my double root. So I come up, go down, I bump, and I go back up again. And again, we're just looking for approximate, showing me that you know the squared means it's a double bump, it's a double root, and going from there. Write an equation that has these zeros, okay? Again, we're making binomial terms that if I set them equal to 0, I'd get these solutions. So basically, I'm changing signs on all of these. Take them 2 at a time, FOIL them out. And then again, some of you have found that using the box can be helpful. And then I can just fill it in. And again, be careful when you're filling the box, you're multiplying. So if there are multiple exponents, you need to go ahead and add the exponents. And once the box is full, I can go ahead and combine like terms. Notice, no more messing with the exponents once the box is full. No good to go. We're almost there. Find all the roots, real and imaginary. Lots of calculator practice, which is good. It really helps in a lot of different areas, especially as we move forward. So let's get this finished up. Okay, we need to find a rational root. Well, I see one. X is -3. So it says use synthetic division to find the polynomial is a factor of a linear and a quadratic. Now be careful. It's x equals, so I'm not changing signs. I don't see any holes. That's always nice. Multiply and add. Multiply and add. Multiply and add. Good, I got a 0. It means that's a root. I started with a degree 3. Work my way down. So when it says write it as a factor of a linear and a quadratic, here's my quadratic. And there is my linear. Because remember, x equals -3, I'd have to do the opposite. Because if I set that equal to 0, I'd -3 from each side. That's what I'm looking for here. So don't be content with just this. Do it. And then to find the remaining roots, I'm going to take this one that wasn't factorable before, and I'm going to plug it into the quadratic formula. So b squared minus 4ac over 2a. So let's see, 16 plus 4 would be the square root of 20. Oh, let's see. Square root of 20 is 4 and 5, so 2 square root of 5. You get this far, don't blow it now. Divisible by 2 on all of those. 1, 2 answers, 3 answers, degree 3. Yeah. Last page, here we come. Now you can see why this test takes 2 days. So find all the zeros. All right. Let's hope for lots of ones that just show up when we type this in. go. And, oh, maybe. Let's check the table. -1. Nothing good that way. Oh, 3. Oh, come on, give me all 3. Woo! 3 answers, 3 answers. Done. Don't even have to play with anything else. That's what I like. All right. X to the 4th plus 8x to the 3rd plus 3x squared minus 20x. Go. Okay, degree 4. Lead coefficient 1. Okay, zeros. I'm gonna get lucky. Okay. Got 1 at 0. And we're not going to get much other help. So, okay. Let's go ahead. We'll use our calculate menu. Go ahead and find this one over here first. So, 1.31. Still got to find those other 2. So back to the left we head. To the left. There's my blinky guy. To the right. -2.12. And I got one more left way over here. Well, I can't see it. Okay. Let's get an idea here from our chart. When I get over those negatives, whew, they're getting kind of big. We're talking maybe, I don't know, maybe down to -500 here. Let's see what happens. Okay, I can see that now pretty good. It's right there. Okay, I want a 0. Here we go. Left bound this time, notice, is going to be above the line. So that's to the left of my 0. Right bound, anywhere to the right of it. -7.20. Because remember, E just means fancy way for 0. There's my 4 zeros. I'm done with that part. Find the ordered pair for the max. You're like, wait a minute, the max? I see the min. Well, let's find that first then. My min, anywhere to the left of it's good. Anywhere to the right of it's good. So my min is at -5.57, -215.45. Let's kind of try to zoom in here a little bit. Like -5 to 5. I'm still not getting a great view. Let's zoom in with y, maybe if it's not quite so big. -50 to 50. Okay, that's better. I see I have a max here. Ooh, and I have another minimum. All right. Let's do the max first. Enter. 2 enters, so I got a max at -1.19, 16.57. And then I do have a second min, so I'm going to go ahead and get it too. That's going to be important. And that's going to be at 0.76, -9.62. Okay, so I'm going to zoom back out here. All the way back out to when I had those really big values, because that gave me my best picture of the whole graph here. What I'm also going to do, and you'll be able to see it here in a minute, I'm going to draw underneath. I'm going to do a sketch based on what I've seen when I've done my zooms of what this is going to look like. It's not going to be perfect, but I know it's going to kind of look like that because I know I have 2 minimums and a maximum. So I'm going to go ahead and I'm going to label those on here. So my maximum value right here, again, only the x's go when I'm dealing with these. And then my 2 minimums are in those 2 spots. Because now, when I'm figuring out increasing, decreasing, and I start at the left, I notice I'm decreasing. So I'm going to go from -infinity until I reach that first min, negative 5.57. And that's why I like writing them on there, because I'm not tempted to use the y's, because if I use the y's, I'm wrong. So then starting at that negative 5.57, I'm going to go until I get back up to my max, negative 1.19. But then the whole thing starts over and goes until I get back to my next minimum. And then that changes and goes back up again and keeps going up as it goes to the right. So you see why making my little sketch might be a better idea than even using the calculator, so I can see what's going on. And I'm also going to have a real good view of the end behavior. Again, with my x's, one's positive, one's negative. It doesn't matter which order you do these in. The y's are going to be what matters. As x is going to the right, y is going up. As x is going to the left, y is going up. And finally, state the domain in interval notation. Keeps going to the left, keeps going to the right, like it always does. State the range. Now be careful. Bottom to top. This doesn't go down forever. It does go up forever. Where's the bottom point? Don't use negative 5.57. That's an x value. What's the lowest y value? Negative 215.45. And I'm good. Okay, lots of little things here. Lots of detail work to pay attention to in this unit. All right, last one. Same stuff. So one last poke of the calculator here, and we should have you ready for this here test. All right, 4x squared minus 5x to the third plus x plus 2. Go. Okay, this doesn't look real complex. This is good. Degree is my exponent, lead coefficient. Odd or even, you go with now. Ooh. Now, Mr. Harty, what do I do here? Well, wait a minute. What have we already done that we already got a little careless with? Yeah, what's the largest exponent that you see? It may even pay to rewrite this. My degree is 3. My lead coefficient is negative 5. This is odd. Be careful. Okay. Name the zeros. Well, I'm looking, I'm like, well, I only see one there. Okay, and again, we're just looking for the real ones. So if it happens to cross, we'll just use it and go, but it doesn't. So we'll get a 0. Word to the left. Word to the right. 1.23. Find the max. I can see both of them this time, so this shouldn't be real tough. It's right up here. So somewhere to the left, somewhere to the right. 0.64 to 0.97. One more time for my min. We're good, and we're good. Negative 0.10, 1.94. And my end behavior, again, as x approaches infinity, as x goes to the right, what's happening to y? It's going down. What happens as x is going to the left? Y is going up. Study well. Go back over things that you've had trouble with. Again, this is going to be in parts, so come ready to go tomorrow on about 1 through 35 like we had in the first preview.